Hi guys, we're going to be talking about wobble PCR. This is a little PCR trick that you can use to make very small parts. So if you have a part that is, say 30 base pairs and up, I think it's like, what's the rule of thumb? I think it's between 30 base pairs and 150 base pairs. Wobble is a technique for you. So it's very simple. It just involves two oligos or two primers, and all you got to do is take one oligo and you just have it chilling here. Then you take another oligo and you also have it chilling here, and it's just kind of, they're floating around, and you have a little bit of homology, and then boom, they snap together. And now we have a homology area, which is, let me draw that in. So we have homology region right here. We let that anneal. And after it's annealed, we just let it extend. So this oligo extends in that direction. This oligo extends in that direction. Probably should label it. So we have 5 prime, 3 prime, 3 prime, 5 prime. So if you haven't figured it out yet already, our oligos have a little arrow. That arrow gives the directionality. The 5 prime does not have the arrow, and the arrow is at the 3 prime. DNA goes from the 5 to the 3, so in the direction of that arrow. So it's pretty much as easy as that. So how I go about designing oligos whenever I want to do a wobble PCR, I basically just take the sequence of the DNA that I want to be working with. So I think about the end product, which let's say is probably this double-stranded piece of DNA. Then I think about, okay, well, I need two oligos in order to do this. So, and I need the oligos to have some overlap. So I just grab a 20 base pair chunk of DNA in the middle. 20 base pairs is plenty of overlap. So 20 base pairs. And then I have the rest of the DNA. I try to split that in half. So the formula is, if you have X base pairs, what you do is you do X minus 20 divided by 2 equals this region over here. This is going to be that value, which we'll just say, I don't know, how about we'll call it N. So that you're going to have N base pairs on either side of your homology region. So it makes it really easy to figure out how to design your oligos. So basically, here's your 5 prime. Let me change colors real quick. So you have your 5 prime, and you have your 3 prime, and you know that you need to have this 20 base pairs. So all you say is, okay, well, our N, we'll just say our N is 30 base pairs. So 30 and 30. You just count to 30. So 1, 2, 3, 4, 5, 30. And then you add on another 20 base pairs, and that's your first oligo. And you can just order that. And then you do the exact same thing. You count 30 backwards, and then you go another 20. And you make sure that these homology regions are the same. That's a little QC step that you can do. If they're exactly the same, you've done it right. And then once you have this little strand of DNA, you reverse complement it and order it. And that's all you really have to do. Now, if you do this, you're going to get a chunk of DNA, but good luck cloning it. So realistically, you're probably going to have to add on a little bit of extra stuff. Maybe you have a couple of restriction sites, an eco, a bagel maybe. And then over here, maybe we'll add a BAM. So that's really all there is to it. I'll just do one more quick run through. So let's just say that I want to wobble an 80 base pair part together. So, whoops, we have 80 base pairs. This is the part that I want. So first thing I'm going to do is I'm going to add on the restriction sites that I want. So in this case, we're going to put a BAM site. So BAM. And we're going to have 5 prime spacer, or I'm sorry, rather, well, it is going to be a 5 prime spacer in the oligo, but we're just going to have a 5 base pair spacer for our part. And on this side, we're going to be putting an eco and a bagel. So eco and a bagel, that's a B. And we're going to be having our 5 base pair spacer. So now we've gone from a regime where we just had our 80 base pairs that we wanted to amplify to something a little bit more. I don't know what this works out to, but you know, here's 10 base pairs, here's another, I'm sorry, here's 5 plus 5 is 10, that's 6 plus 6 plus 6 is 28, plus 3 base pairs in between those are going to be, I can do math, 34. So that's an extra 34 base pairs, so 80 plus 34 is going to be 114. So 114 minus 20 is 94. Is that right? Yes. Cool. So what we're going to do is go 94. Oh, wait. I'm dumb. Sorry. So this is 94 equals 94. And 94 divided by 2 is 47. So all we got to do is count 47 base pairs this way. And we'll just say that's 47 base pairs. And then we'll switch colors, and we're going to count 47 base pairs this way. And then we're going to switch colors one more time. And then to each of those 47, we're just going to add an additional 20. So 20 and 20. So now this, so final time I'm going to switch colors. This section is going to be what we're going to be using for our first oligo. And we can just order that sequence of DNA from there to there with our homology region. And this section right here, from here to there, is going to be the reverse complement of the oligo that we want. So we just make sure that we get homology here, then we just reverse complement and order. And then what that's going to look like is we're going to get a nice big oligo. So we have our 5 prime, 3 prime, and then we have our eco, we have our bagel, and then we have the 5 prime of our part going from there to there, and then we have the same thing over here. We have our one big oligo, we have a BAM site. I'm trying to line these up as much as I can. And this is the 5 prime over here. And then after that BAM site, we have our part. And in between, we have our homology region. We have our area where they overlap. And then we can make this all line up. So there's our homology region. This is 20 base pairs. This is 47 base pairs. That's a 7. Sorry about that. And we have another 47. We just put this in the thermocycler and press go. And we get this small chunk. All we got to do is digest it with eco and BAM, and we can pop it into a vector that has also been digested with eco and BAM. And that's pretty much all there is to a wobble. If you have any questions, let me know, and I think that about does it.